Today we're going to be using several transformations to, guess what? Anybody know what we're going to do? Yeah. Sorry? Find what the variable is equal to, which means solve for the variable. Exactly right. Because so far, if you look at 3.1 and 3.2, we just did it in one step. Now, guess what? We're going to combine, like adding numbers together to both sides or multiplying both sides by. What do we call adding same number to both sides of an equation? That's called the addition property of equality. Hello, we learned this one. What do we call the property where when you transform equations, when you add both sides by the same number, it's called the what? Addition property of equality. And what do you call when we multiply both sides by the same number to an equation? Multiplication property of equality. So we'll be using those. Do I like subtraction and division? Not really, but could we use them? Yeah, it's fine. Okay, so here we go. So let's look at our first one. Here's our first equation. 2x minus 7 equals to 4. Okay. So in this problem, it won't be just one step. It will require 2 steps, I think. Okay. Anybody know what we could do to get x by itself? All right, a lot of you know. Okay, Michael.
First you add 7.
Yeah, first you add 7, right? Get rid of that, right? This is really adding -7, right? So you add 7 to both sides, right? Now, what about, could I get rid of that 2 first if I wanted to? Yeah, I could do that. But is that the best way? No, I mean, you could do it. Why wouldn't getting rid of that 2 not the best way? Yeah, Dana? I'm sorry? Exactly. When you divide both sides by 2, you have to divide both of the term, right? You got to divide the whole left side. So this will be fine. The first term, it will be x, right? If you divide that by 2. But this will be -7/2. Does that make sense? And I mean, you could deal with fractions, but isn't it better to get rid of that number? So if you want to gather all the numbers first, okay, then right, get rid of the numbers that's multiplying the variable. Does that make sense? So of course you're right. We're going to add both sides by 7. Or of course we get 2x equals to 11. Now all we have to do is divide both sides by 2. 11/2 is your answer. Is that okay?
So
Yeah.
mixed fractions.
Yeah, you don't need to, unless I ask you, you don't need to write as a mixed number. We like improper fractions anyway. By the way, should you write this as a decimal? No, okay, we don't like decimals either. We like fractions, especially improper fractions that are simplified, right? If this was like 22/4, of course you'd have to simplify that, right? But you don't need to write it into a mixed number. Yeah?
That wasn't 11. Would we put it as 5? I mean 10.
If what?
Yeah, 11 was 10.
Sure, of course. Yeah, if 11 was 10, of course, you don't leave it as 10/2. You write 5, of course. You always want to simplify. What's it set up there, guys? Always? Simplify. You always want to simplify. Does that make sense? Any question? May I move on? Okay, so, by the way, let me show you this. So, yeah, question?
Is it okay if we put x equals 5.5?
Yeah, but that's fine, but I like fractions. So if you're going to get 5.5, you know it's going to be 11/2 anyway, right? Before 5.5. So leave it. It's easier. So let me show you why we want to get rid of the 7 first, not 2. Is that okay? You don't have to write this down. I just want to show you. So don't write this down. So imagine that in the very beginning we had x. Yeah. From this x, they made this equation. Guess what they did to this x to write this equation? They first multiplied this x by 2. Then guess what they did to this expression? They then subtracted 7. Does that make sense? So in order to undo to get to x, in other words, in order to go back, guess what we're going to do? We add 7 first. Does that make sense? Sort of undo what was done to it last. Sort of like a, I like to think of this as sort of like a box. In the box there was x in there, right? And then they put a box with this x, another box, and then put 2x, and then another box. Minus 7. So how do you get to that x inside the box? Well, you got to get rid of the box that's outside first. And so you add 7 to get one of that box outside, you know what I mean? And then divide by 2 to get that x. You see what I mean? That's sort of opening that box. I don't know, whatever you want to think of. Okay, does that make sense? Okay, and of course, some of you say, well, couldn't we divide both sides by? It's called, by the way, it's called inverse operation. How you go backwards, how you undo things, okay? By the way, if you were to divide this by 2, let me show you how this works, okay? It still works, but you got to divide 2 to both of these terms. And as you said before, you get 7/2, right? You see? And of course, 4/2 is 2. then you have to add 7 over 2. Do we get the same answer?
Yeah.
Yeah, we do, right? Because 2 is really 2 over 1. You got to multiply top and bottom by 2, right, to get a common denominator, right? Did we get the same answer? Yeah, 11 over 2, which is easier. Yeah, the first method, right? Sort of like you undo the ones that was done to this at the opposite way. You know what I mean? Like sort of a box. You open the last layer, outer layer, and go all the way inside. Anyway, okay, let's go to example. Here's example 2 again. Not again. Here's example 2. 1 over 5x minus 9 equals to 3. Oh, okay. Okay, so let's think of this as, well, in the beginning we had x, right? And then what did they do to x here? They divided by 5, and then they subtracted 9. So in order to undo it, which one should we get rid of first? Think about it. What is the last outer layer? Okay, you can think about that. Yes, Livy. Add 9. Does that make sense? Because we did that the last thing that was done to x. So we add 9 to both sides. Of course, somebody tell me what to write here. If I add 9, I get what here? How about? Yeah, how about? How about Carolyn? What do you think?
1 over 5x equals 12.
12. And Patty, what do I need to do next after I get 1 over?
You multiply each side by 5.
Exactly right. Because it is the x is being divided by 5, right? 1 over 5x is the same as x over 5, isn't that right? Or you could think of it as, what's the reciprocal of 1/5? 5. So that's why we're multiplying both sides by 5, right? If you like, we could write it as 5 over 1. Okay. And when I do, right, we get x equals to 60. Any question? This is pretty straightforward. And if you have time, right, like on the test or at home, you have time, right? Is there a way to check and see whether we got the right answer? Jason, what can we do?
Like, when you get x equals 60, you take the 60 and put it where the x was.
Yeah, you plug it back to the original equation and see if the left side is equal to the right side. Does that make sense? And as you can see, it's going to work, right? What's 1/5 times 60, guys? 12. And what's 12 minus 9? 3. You see? 3 equals 3. You get the right answer. Easy? Yeah.
Are we supposed to do the second step?
Second step? No. You don't have to write down x. You don't have to do that part. No. Yes. Just this is what I'm expecting to see for your homework tonight. Yeah.
We have to like show the step like 5 times 1/5 and then 60.
Oh.
Like 5 over 1 times 1/4. Right? Can we show that?
No, this is good enough. This is what I have up here. This is what I want to see. Is that okay? Just do it like this. All right, let's look at the next example. Okay, this one is a little bit different than the first two examples. Go ahead and write this down. K minus 4 over 2 equals to 13. Okay? Now, anybody see what the difference is in this one? What did they do to K first? They subtracted by 4, then they divided by 2. So what do you think we should do to undo what's being done to K here? Yes, sir? Multiply both sides by 2 first, right? So Matthew, if I do that, can you tell me what I get?
K minus 4 equals 13.
Exact 13?
Yeah. 26.
26. You can't just multiply the left side by 2. You got to multiply both sides by 2 right here. I wrote it as 2 over 1. Do you see? And do you see how the 2 over 1, the 2 on the top and the 2 on the bottom will cancel out? And which will get you as x minus 4 equals 26. Yes, sir. Question.
Why doesn't it turn to k minus 8?
Good question. Why doesn't it turn into k minus 8? Why should it turn into k minus 8, Eric? Okay. Why do you just tell me that it should be k minus 8, not k minus 4? Because did you distribute 2 to 4 here?
Yeah.
Okay, you can think about that. If you did, Eric, you're going to multiply this 2 to k, and then you get 2k minus 8 over 2. Well, 2k minus 8 over 2 is this 2 on the denominator, right? Doesn't it become 2k over 2 minus 4 over 2 also? So the 2 divides both of the terms. Do you see that? Or you could just simply think of it as 2, the numerator and the denominator, they cancel out and you get k minus 4. Does that make sense? So since 2 was dividing k minus 4, if you multiply by 2, you just get k minus 4. Yes, question? Yes, if you just divide 2 by negative, so you get k minus 2 of here, that would be wrong. Why would that be wrong? First of all, let me finish. I'm going to add both sides by 4, I get 30, right? Some of you were saying this. Could we do this? K minus 4 over 2 equals 13. Could we just do this? And write k minus 2 equals 13. This will be?
15.
This will be wrong, right? Why would this be wrong, guys? Why can't we do this? Why can't we just cancel out? Doesn't 2 go into 4 twice? Who thinks they know why? Yes?
Divide all of it.
Yeah, you gotta divide all the terms. It's k minus 4. 2 divides also k, not only the 4. So if you're gonna do this, you have to write half also, or k over 2. Does that make sense? Karen? So you can't do it that way, right? If this was k times 4, you could do it, because you could divide both top and bottom by 2. Right? So you could think of this as k minus 4 over 2 as k over 2 minus 4 over 2. This is what it means, right? So you can't just cancel these out. You still have k over 2 here. Does that make sense? Please be careful, okay? This will be wrong, okay? If you did that. I mean, this part is right. This will be wrong right here. Question? Can we add 4 to both sides first? Does that help us? If you do, it doesn't get rid of this minus 4. Because this is really, like I said, k minus 4 over 2 really means k over 2 minus 4 over 2. Right? So if you subtract, if you add 4 to both sides, it doesn't get rid of this 4, does it? Because of that 2 on the denominator. It's not the same. So you want to get rid of that 2 on the denominator by multiplying both sides by 2. Does that make sense? Yes? Okay? Do you see what I'm trying to say? Okay, let's do a couple more examples, see if that makes sense. Take a look at example 4 here. 40 equals to 2x plus 3x. Okay. This one looks a little bit different also. Doesn't it? 40 equals to 2x plus 3x.
Is there a homework tonight?
What?
Is there a homework tonight?
Is this on your homework?
Yeah.
Yeah, something like this. So what can we do on this? What can we do on this problem? By the way, what's different in this example? Yeah. Yeah, there are 2 like terms. So guess what we have to do first? You're exactly right. Yes. How about Angel? Combine them. So what do we get here? 2x plus 3x is, of course, 5x. And you guys remember it's because of the what property? Distributive property, right? So you don't have to write that second step. I just sort of a review, right? The reason why 2x plus 3x is 5x is because of the distributive property, right? Backwards. So of course, then if you have 40 equals to 5x, what do we do here next? Lindsay? Yeah, you divide both sides by 5 because 5 times x. So undo that, divide. So you get x equals to 8. Okay, any question? Easy enough? So if you're going to simplify, if you're going to have problems like this, you should always simplify. It just makes it easier, okay? If you could simplify before you could solve for one of the variable, you should do that, okay? It just makes it easier. Any question? We good? Okay. Okay, let's take a look at example 5. We got 8 times w plus 1 minus 3 equals to 48. So before we do this problem, let's think about what happened to w. We had w, right? What did they do to w first? You had w, they did what first? Added 1, right? Then, what did they do to this w? Multiply by 8, right? Then they subtracted by 3. So in order to undo it, let's go backwards. What should we do first? How do you undo these things? Yeah. Add 3. Then, what are you going to do? Then you get this. Then what are you going to do? Divide by 8. Then what are you going to do here? Subtract 1. Do you see what we're trying to do here? So first, we're going to add 3. So Samuel, tell me what to write here. Samuel Lee, what do I get? When I add 3, I get? Yeah. On the right side. What about on the left side? 8 parentheses w plus 1. Okay, a lot of time people wants to just, they want to distribute this 8. You could do that, but if there's just number on the right side here, you could simply do what? Just like what we just talked about. We could? Carolyn, what should we do? Think about what we had here before. Remember, the last thing that was done to us was they were subtracting 3, so we added 3. right? So they're multiplying this w plus 1 by 8. So how do we undo multiplying by 8? Yeah, you divide by 8. Could you distribute if you wanted to and solve that way? Yeah, it's fine. There are many ways of solving, but I think if you just have a number on the right side, it's easiest if you just divide by 8, right? Do you see what I'm saying? And so you just get w plus 1 equals to 51 over 8. Right, Chris? Okay, then what do I do next here? I subtract 1. Exactly right. How do I subtract 1 on the right side? It's 51 over 8, right? So how do I subtract 1? What's the easiest way to do this? Royce? Make it a common denominator. How can I write subtracting 1? What is the denominator of 51 over 8?
8.
It's 8. So Dakota, what should I rewrite subtracting 1 as? 8 over 8 is exactly right. Because what's 8 over 8?
1.
Isn't that 1? So just subtract 8 over 8. Instead of writing 1, right, you could do it. Isn't it best to write it as 8 over 8? Does that make sense, guys? I just wrote it as adding negative 8 over 8, which is the same as subtracting 8 over 8, right? Do you see why I chose to write 8 over 8? Because they have a common denominator now. What is the answer for this? How about Michael?
43 over 8.
Exactly right. How many people got 43 over 8? Any question? Does this make sense? Are we good? Okay. Then why don't you try the next one yourself? Okay. Do you have all your? You all have your checking for understanding paper? Okay. Everybody, try this yourself. Go ahead and try this problem. Without any help, we'll go over this right after. Go ahead. Okay. Okay. Then switch with someone else. Go ahead, everybody. Let's see how many people got this right. You should have a pen out. Okay. Everybody, get out a pen. Here we go. First of all, let me ask you this. Everybody, who does not have someone else's paper? Raise your hand. Okay. Now, how many of the person's work? Are we okay? Okay. How many people wrote down this first? 10, negative 10 plus 4, isn't that equal to negative 6? Okay, can we do this? Okay. This is wrong. Why can't we do this, guys? Isn't negative 10 plus 4 negative 6? Doesn't that make it a lot easier? Why can't we just do that? It's right there. Negative 10 plus 4. It's still inviting. Let's just do negative 10 plus 4. Why can't we? Why would that be wrong if we do that? 1, 2, 3, 4 people see it. Okay, how about what do you think, Lilette? Exactly. You have to multiply first. If you're following the order of operation, you gotta multiply. You cannot add first here. Does that make sense? Remember we did this sort of problem before, right? Just because it says negative 10 plus 4, you can't just do that because there's a multiplication. You see what I mean? So what should we do first? Okay, let's think about this. We have P first. What do they do to P? They multiply 3, right? Then they add it by 10 and multiply the whole thing by 4, and then they added negative 10, right? So how do you undo the last thing that was done to it first? Class, what should we do first here? How about Joseph? I'm sorry? Yeah, what do we need to do? What's our first step? Add 10. This is the first step, guys. Okay? Does that make sense? Yes.
Well, they didn't show that they added by 10, they just wrote that.
That's okay. That's okay. And then once you do that, you get then 4 times 3p plus 10 equals 28. Then, of course, question? Oh, they could distribute first and then simplify and then get the right answer. That's fine. But since if you're doing if you're following what we're doing here, I think it's a little bit easier, right? To think what they did first, and then you sort of undo them. Then you divide both sides by 4, right? Could you have distributed 4? Yeah, you could have done that, but isn't this easier? Then you get 3p plus 10 equals to 7. Then you, of course, what? Subtract 10 again and divide by 3. You get negative 1 as the answer. Is this the only way? No, you could have actually distributed it. That's fine. But you have to have the right answer as -1. But isn't this easier?
Yeah.
Yes? Kind of undoing what they did, right? In the opposite order. Yeah, it's like sort of like a box. All right, raise your hand if the person that you graded got it right. Good. Raise your hand if the person that you graded got it wrong. Oh. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people? Wow. Okay, period 1 beat you guys because they only had 8 people that missed. All right, now give it back to the person. Take a look at what you missed. Okay? Go ahead, guys.